Okay, this is part 2 of ChemQuest 34% yield. We left off on question number 5. Consider the double replacement reaction of excess sodium chloride with 203.9 grams of silver nitrate. And if you are able to produce 150.4 grams of silver chloride, what was your percent yield? First, we're going to write out the balanced equation. NaCl plus AgNO3 combine to form NaNO3 plus AgCl. So first we multiply the initial mass of silver nitrate by the molar mass of silver nitrate. So 203.9 grams of AgNO3 times 1 mole of AgNO3 over 169.87 grams of AgNO3. We then multiply that by the mole-to-mole ratio between silver chloride and silver nitrate. In this case, it's 1 mole of AgCl over 1 mole of AgNO3. That then will give us the molar mass, or that will give us the moles of AgCl, which we then multiply by the molar mass of AgCl, which is 143.32 grams of AgCl per mole. We then get the final mass of AgCl, which is 172.03 grams. We then plug that into our equation for percent yield. So we plug in the actual yield, which was 150.4 grams of AgCl over what we just calculated right now, the 172.03 grams of AgCl. We multiply that by 100 and we get the percent yield of 87.4%. Okay. Number 6. If you make 46.8 grams of calcium carbonate by reacting 87.5 grams of calcium nitrate with plenty of sodium carbonate, what is your percent yield? So first we're going to write out the balanced equation. The balanced equation is always important because we then can find the mole-to-mole ratio between the product and the reactant. Okay, so first we multiply by the initial mass of 87.5 grams of calcium nitrate. We multiply that by the molar mass of calcium nitrate, which is 1 mole of calcium nitrate over 164.088 grams of calcium nitrate. Next is the moles of calcium nitrate, which we then multiply by the mole-to-mole ratio between calcium carbonate and calcium nitrate. In this case, it's 1 mole of calcium carbonate over 1 mole of calcium nitrate. That then gives us the moles of calcium carbonate, which we then multiply by the molar mass of calcium carbonate to get the grams of calcium carbonate. So 100.0869 grams of calcium carbonate over 1 mole, which we then get 53.37 grams of calcium carbonate. Okay, so then we plug that into our percent yield equation. So the actual yield, 46.8 grams of calcium carbonate over the theoretical yield of 53.37 grams of calcium carbonate, times 100 to get a percent yield of 87.7%. Okay, and that's it for the critical thinking questions.